My guest today is Joshua Gans. Joshua is a professor of strategic management at the Rotman School of Business at the University of Toronto and chief economist at that university's Creative Destruction Lab. Joshua's research specialties are the nature of technological competition and innovation and economic growth, and he is the co-author, along with Ajay Agarwal and Ajay Goldfarb, of Prediction Machines, The Simple Economics of Artificial Intelligence, which is the subject of today's conversation. Joshua, welcome to the show.
It's great to be here.
So the subtitle of the book says that economics of AI are simple. And that struck me as an interesting contrast to the strategic, call it complexity or confusion around what to do with AI. And I'm wondering if you could maybe elaborate a bit on what is exactly simple about the economics of AI.
The title of the book is telling you about the content of the book. And there are complicated things to do with artificial intelligence. But the first place you should start is what is simple. And the general approach in economics is to, when you're understanding a new phenomena like this, is to identify what is being sold and then see what happens to supply and demand. And that's really what we mean by simple economics. So in the case of artificial intelligence, we analyzed the technology and realized that in the current wave of artificial intelligence, what was being sold was prediction, predictive powers, or machine prediction, as we would call it. And so what that meant was that that was what was being sold, and the technological advance was to make those predictions better, faster, and cheaper. In particular, when you make something cheaper, what happens to it? You will end up using it more. And so we would say, okay, this is going to increase the total amount of predictions being used in life or whatever, in the business world. But the other thing that comes when something becomes cheaper is people find new uses for it. And that's particularly tantalizing when it comes to artificial intelligence. Mm-hmm. And so simple is basically those two effects.
Right. And maybe you could dwell for just a second on cheaper, on how you might measure that, because when I kind of the intuitive reaction I have to what's changed about AI, it's not necessarily, I don't necessarily think of it as a cost reduction. I think of it instead of as a capability expansion. Now, I suppose those things are related. Maybe you could talk about that for a second.
Yeah, they're sort of they are related to one another. I think that's how an economist would look at it too. Is that you are able to produce something of greater quality for the same price.
Right.
So that's implicitly a cost reduction. Mm-hmm. I guess we just like to focus on it that way, since it's a little bit easier to sort of comprehend, even if it's not as exciting. The problem with when you think about, capability expansion, you're already into the question of what capabilities.
Sure.
Cost reduction, it's a little bit easier to sort of...
More universal.
Yeah, exactly.
Yeah. And the book has some interesting, call it a framework for advice for organizations that want to think about. And I see that as kind of the motivating force on the book, and maybe you can tell me if that's right, is what do we do with all this? Given these insights and this economic thinking, the framework of economic thinking through this, what can we do? So the book was, in first part, a reaction to what we saw going on out there in terms of discussions regarding artificial intelligence. Enormous amounts of hype. Sure.
A dollop of panic. Am I missing out on something?
Yeah. Or panic of what's going to happen to us all.
Oh, there's that as well.
Yeah. Existential threat.
But from the point of view of business people, sort of like, what should I be doing about this? And terribly unclear answers. Oh, it's going to replace cognitive capabilities, this and that, which weren't really necessarily true. And if that is true, what would you do with it? So our book was designed to say, what is this really? Let's strip away all the hype and throw some economics in, which is something at least business people would be familiar. Mm-hmm. And then say, well, once we've got that, exactly how would you read this book on the weekend and turn up on Monday morning and think about what to do about it? Mm-hmm. And that was really our intention here with the book, is to provide that entree into the whole area.
One thing that doesn't kind of interest me about a comment you made there is the familiarity of economic thinking to business people, and I actually find that that's less the case than I would expect. And so there's many, maybe most, maybe all business people, certainly senior folks in organizations, study economics in some manner, one way or another, be it through some kind of extra training program or an undergraduate, as I did. And I think that at least the jargon of economics is absent from the business world for the most part.
Right.
And the concepts maybe are related, but I don't think that they're actually explicitly thought about. Why don't I see it more often?
Oh, well, that's a more difficult question. I think, I think there's economics and there's economics. I think when you're just talking about the basics of supply and demand, which is
Sure.
really where we start in the book, even though people don't like using those terms because it doesn't sound like you are doing something complex, thoughtful, etc. It still has that familiarity. Somewhere at the heart of it, it's very hard to be a business person without having some grasp of those concepts.
Sure.
Whether you've learned them formally or not.
Yep.
And even more so when you sort of reduce things to cost. I mean, that's sort of something easier to understand. There's a lot of economics that gets built on that. That gets more complex. And in the book, we deal with some of that for sure, because we start talking about, how you'd make a decision under uncertainty and things like that. And then it gets, then it definitely gets hairier. I think business, it depends on the industry. Some businesses are starting to use economics explicitly more and more. And that's beyond the currency trading and other things.
Right.
Used
Yeah, finance is a bit different.
Macroeconomics or, that sort of forecasting. Some years ago, I think Google's the first to employ a chief economist. Then Microsoft and others have all done that. Amazon has I think over 100 economics PhDs.
Yep.
Right at the core of that organization. And so I think that notion is spreading. It started, it's interesting, it sort of started with technology, but it's spreading elsewhere.
Yeah.
But, to be sure, economics in its academic variety had for a long time been fairly inaccessible to business practice. And it used to come through business schools, through things like strategy and things like that, but not really in its, I guess, full glory.
Yeah.
But that's starting to happen now.
And do you think that's to use some economics jargon, supply or demand? So is that the economists aren't interested, or is it that the business people aren't interested?
I think it is, I think it's been demand-led.
Okay. The change has been.
The change has
right.
been.
So business people saying, what do you guys have to say about all this?
Exactly. Starting to realize that, that company over there has an economist who said something good.
Yep.
Maybe we can get one.
Sure.
Is the thing.
A little herd mentality.
Yeah, and also that coupled with the options for economists in terms of careers were, either government or academia, basically,
Right. Yep.
were the two main options, especially for people with PhDs. And I think it's really interesting to see that the private sector has opened up as a significant avenue. I know many economists who would have otherwise been on a clear academic path who have moved into the private sector, say, I don't want to deal with this stuff, and moved over. I could do real economics there, I couldn't do it.
Yeah. In some way, I think I might even question my own premise in asking these, because it is unique amongst economists to have a significant presence. Unique amongst academics for economists to have a significant presence in government and/or business, for that matter. I mean, it's
Right.
Not many academic disciplines make any kind of crossover whatsoever. So why should we think that economists should?
Well, no, that's true. Although that's also changing as well. I mean, we're talking here about artificial intelligence, and if there's ever a place where academics and business have sort of fused together, it's in that field. All of the main pioneers of artificial intelligence, almost all, are not now purely academics. They tend to be half-time at some other companies. So, and their students as well.
Yep.
So I think there are situations in which, maybe always has been more integration versus others. It's rare amongst social science.
Yep.
Social
Right.
science is where it's
Yep.
rarer, and economics has had bigger influence all over the place in that regard.
And maybe you identified an important idea there, which is a lot of technology emerges from academia as well, from engineering departments and computer science departments.
Yep.
And so they sort of naturally dragged along a few of their friends, maybe, and said, you should join us. You'd have something to say here.
Right. And I think that's definitely, well, it's certainly definitely true with the recent advances in artificial intelligence.
Yep.
It was all developed in academia first, all of it.
Yeah.
It's quite incredible, really.
It is. And so let's go back to artificial intelligence. And I asked the question a minute ago, but I pulled us off track. What is the evaluation framework, or maybe you could sort of briefly address what you put in the book as saying, here's kind of how you should think about it, Mr. Businessman.
Right. So artificial intelligence is this word that connotates a machine taking over thought processes of various kinds.
Yeah.
Certainly, 50, 60 years ago, that was the image of it. In popular culture, it's the image of it. But what really has developed in recent times is an advance in what is called neural networks. So, 30, 40 years ago, some people had the idea, well, it's hard to think about how we would create intelligence. Let's take what we know about the brain, a bunch of neurons sort of communicating with each other, reinforcing links and things like that. Let's do the computer equivalent of it, which is a vastly simplified version.
Yeah. In retrospect, very ambitious.
Yeah, very ambitious, but very, even so, I mean, the number of neurons that we or even, insects or something have is far less than what we can model, simulate on a computer. But that was the vision, and not much came of it for a long time. But then these 3 or 4 pioneers of artificial intelligence, Jeff Hinton, Joshua Bengio, and Jan LeCun, about 15 years ago, had the idea of various advances, but the idea was, rather than having one sort of layer of neurons, what if it was like a whole hierarchy of them? Mm-hmm. And so you had sort of more complicated sorting that could occur.
Deep neural network in the jargon.
That's right.
Yeah.
Deep neural network, deep learning was the term. And they had to do some other things as well to advance that. Jan LeCun was able to think about, if I want my neural net to look at images, it doesn't help if I do the computer thing and have it look pixel by pixel.
Right.
It matters which pixels are next to each other. So he came up with a way of reading in image data that allowed those sort of proximity associations to be part of the data that's coming in. And so those advances, yielded results. So in image recognition, which is basically where you present a computer with a bunch of images and you ask them to label them. What is this? Basically, what is this?
Yep.
And what we're asking, I'll come back to this in a bit. We're asking, what would a human think this is? And sometimes, what is it actually?
Yeah.
But at initial, it's like, what would a human think it is? So that had, a bunch of images that had already been labeled by people. Mm-hmm. And then they wanted to see how accurate the machines were in doing it. And they were plodding along, and then Jeff Hinton and his team threw deep learning at it, and it just skyrocketed, in terms of accuracy. And all of a sudden, we're now down to, depending on the domain, it can be more accurate than people in sort of identifying these images.
That's amazing.
And that was in a very rapid period of time, and it was a time where I believe no one outside of these pioneers, and maybe not even them really, thought that this was going to be a promising area. There was a lot of skepticism. But that's worked. And so that's worked on not just image recognition, but on speech recognition, translation, a whole lot of problems that were like the cornerstones, and all the way up to the ability to play Go and now be the best
And chess.
In the world, and chess. Well, chess was already sort of cracked.
True.
Using old methods, but
Yeah.
they can do this too
Yeah.
now. And there's just a whole lot of applications like that. And so that was really the advance there. Not surprisingly, that got people very excited. And I think partly they also had to wait for a few things to occur. They had to wait for... it'd be very easy to read lots of, images and data to kind of train these neural nets, and they had to wait for computing power to get good enough to do that same thing as well. Mm-hmm. But that sort of like all came together in the early 2000s, and here we are today.
So there's an interesting framework as I guess he's an analyst, works for Andreessen Horowitz, guy named Benedict Evans, you've probably heard of.
Yes.
And he has a framework for evaluating AI. He wrote a blog post a couple months ago where he said really there's three ways of thinking about the application. The first is do the things we can already do, but do them a bit better. Do ask new questions of existing data that we already have. And the third is bring in new data.
Right.
Now, the third one is the most advanced one, the one that's the most sexy, let's call it.
Yes.
And that's what you spent your time a second ago talking about.
Right.
Yet the first two are really probably where we're generating a lot more of the value,
For sure.
I would argue. And so how should we think about that and as kind of the evolution of the ability of AI to do things we already do, but a little bit better, and
Right.
what new applications can we find, but are a bit closer to home?
I mean, the issue that I have with that setup of, what is it doing? It's not that it's wrong, but it's like hard to see.
Right. Interesting.
Because, we're going to learn stuff from data. This is true. And so, that data, more data, new data, the whole thing. It tends to put an emphasis on, finding the data. But the way we see it, it's more finding the problem. And so, we talked just a second ago about image classification. And what image classification is fundamentally a prediction problem. Mm-hmm. We tend to think of prediction as being about the future.
Of course.
About, what's the weather going to be like tomorrow, and of course it is. And we use data from the past to give us a signal of that. But what image classification is prediction of the present, or prediction of, what would someone call this? Mm-hmm. All the way leading up to what is it actually. But someone has had to tell the computer what it is.
Train it.
Well, so that has to be programmed. But once you've worked out what it is, then it's a matter of taking some sort of image that could be anything and saying, is it this or not?
Mm-hmm. Okay.
And so, because the machine, aside from one case, the machine doesn't know what it's looking at. It doesn't have a inbuilt label for things that can describe to us, whether it be a tumor, malignant or not. But if you associate the word with the thing enough, it learns it.
Labeling stuff.
Yeah, and it's like kind of babies learning to speak. They learn it. Now, babies learn how to classify things at a much faster rate than the computers do. The computers need millions of images, but they'll do it.
Yeah. Babies are almost pre-wired for these certain categories.
Well,
it would seem.
That's one possibility, but probably not. No, you teach a baby what an apple is, or when they can speak, they can recognize what an apple is the next time that's put
it's
in front of
incredible.
them. Right?
I have a 2-year-old right now.
Yeah.
I have my kids are 6, 4, and 2, and each of them have gone through it very recently, the stage of each of them. And with in the back of my mind thinking, as I do sometimes, about AI. And just marveling, actually, at how they can do that.
Yeah, so there's
quickly.
much more going on there.
Yeah.
I mean, it's the same function. There's a predictive element to it.
Yeah.
It just is, compared to our AIs, it's so far advanced, whatever's going on in our minds.
It reminds me, it makes me think a little bit of one way of being amazed at, in some ways, at the original neural network research and what's emerged in it since, but it occurred without too much of an underlying theory of what the brain is doing. So there's a physical reality, right? You have this set of neural networks, and the deepening of the neural network is important.
Right.
And you speak a bit in your book about what I think is maybe the most compelling, or at least the most complete theory of the mind that I've seen before, which is the way in which it's a forecasting machine, and that's how it developed, and that's what it's supposed to do. And maybe you could talk a bit about that and what we think we know about that.
Well, so there's a couple of layers to that. Well, one is there is a view out there that all we do is prediction.
Yep.
We may think we're doing more than that, but we're not.
Yep.
This guy Jeff Hawkins, I think he was the founder of Palm, decided to write a book putting forward this view. I'm not sure I believe that as fully. I think there's more going on there, but, I understand that perspective. And what he's basically saying, you can get a long way with prediction.
Yeah, sure.
But there's another element to this in terms of the mystery of this. It's actually less mysterious than people like to believe. I know we get a lot of articles saying, I don't know how it came up with this, and it seems to work, and no one knows why. Well, so economists tend to also have a close relationship with statistics. And, what is going on inside the computer is it can't be magic. It has to be a set of equations.
Yeah, it's moving around.
Yep. That's the only way it works. And so, several people, and most recently an economist at Yale, have gone back and looked at all these different methods and so on, and found that really they are just versions of statistical methods that we already knew about. They're just operating on steroids, and they've got some extra optimization algorithms to get you to the least square error solution much quicker and stuff like that.
Yeah.
But fundamentally, it's just that statistics. It's same sort of processes and things like that. And, that's useful to know. So what that's basically telling us, and this is why I come back to Benedict Evans, is sort of like, it's not just about the data, it's about the model that's being built and other things like that. There's more to statistics than just the data. It's how you put these things together. But it's really just that. Now, that doesn't mean that it's not, exciting, important, revolutionary. But it is just, the reason this is important is that any prediction you get out of this has to obey the laws of statistics. So there are situations in which, it can come up with predictions and understand and seize things and understand the complex data in a way and filter it down in a way that we can't. And we were unable to do with previous statistical tools. So that's very exciting.
Not consciously, anyway.
Not consciously, yeah. And so that seems, maybe not even able to do, but it seems sort of magical in that regard. But we also know, because we understand that this is statistics, as far as it can go. For instance, we like to call this prediction machines, and we like to, in the book, experiment with the idea of what if you dialed that up and made it better, what would you be able to do? But there's a limit in some situations of how far you can do that. For instance, when you toss a dice, it's going to be one, and it's a fair dice, it's going to be one of the 6 sides. No prediction machine is going to tell you which one is going to come up. I mean, unless it can, and people are going to think, what if they could analyze the structure of the dice and see flaws?
The physics.
But if it truly is a fair dice being tossed, they can't do any better than what we already know.
Yeah.
So there is a limit there. And it doesn't matter how many dice you rolled.
Sure.
In terms of the data, you're not going to improve it. And that surely is going to exist down in the world as well. There is some fundamental randomness that you'll never be able to quite work out. And so that's going to affect when AI performs today or in the future as well. And I think it's a way of at least thinking to yourself whether this thing is going to have legs, if it's going to be able to perform consistently over time.
There's another set of ideas that I came across recently, and I think you're probably familiar with Robin Hanson, economist, yes. And he had a post where he talked recently, which really I thought was really thought-provoking, where he talked about how the observation was there were different the diversity of, call it, genotypes versus phenotypes in the world. And so he's saying what was amazing was that there's lots and lots of different gene orientations in different, and it's called, I think it was an E. coli was the example, that create only a few different body types.
Right.
And so there's this diversity of the way that he generalized that to something like AI is that there's lots of tools potentially we can use to achieve only actually a narrower set of functions than we might think. So the kind of implied theory of the brain there is that the brain is actually a collection of a huge amount of different capabilities, and we don't necessarily touch all of them all the time.
Right.
And the switching of one capability or one, call it, forecasting model to another, and here's how we bring it into AI, where the implication for AI there is actually you need dozens, hundreds, thousands of different models that will be distinct in how they might predict something, but the assemblage of them all and the interplay between them, being able to switch between them is actually what intelligence kind of really is, and there's no general solution. So there's no just one neural network which can handle everything.
Right. I can see that. I have no idea.
Yeah.
I have no idea. I think at the moment, in terms of the sort of practical applications, we're far from, wanting all these different models. We're just trying to find applications for a model.
Yeah. Well, what's interesting about it, and what's kind of encouraging about it, is that there's another kind of theme in the AI world, is that progress doesn't happen, right? So every time there's a whole bunch of hype, then it always fails.
Yeah.
And what I find encouraging about that framing of the problem is that actually what we're doing is adding more and more models over time.
Right.
And so there's this inventory which we're building up, and eventually there is linear progress here. We might not necessarily observe it so much. And so, let's say if in any particular business, you're just waiting for your model to be built.
Right.
I guess.
Right. I think so. I mean, well, you can push that forward and have it built.
Yeah. Yes. Build it
but
yourself.
I think what's different, right? AI's had hype and it's died and hype, but it's never had, it's never filtered into practical use the way it currently has, and that currently has the potential to do so. Mm-hmm. So if AI dies now, so AI died previously because it hit a limit very quickly. Mm-hmm. I don't think there is that feeling that we are even close to sort of hitting limits on stuff.
Yeah.
I mean, certainly in certain applications. I mean, eventually you can't get above 100% accuracy in image recognition, and you probably won't ever get to that. So we're going to hit some points of diminishing returns on specific applications. Mm-hmm. But there are so much more to do. There seems so much more to do, and so I suspect that this will probably have decades worth of legs before we sort of okay, we've gone as far as we're going to go.
Mm-hmm. Well, was there a particular business or two that you've had a lot of experience in, that you had in mind when was there a kind of a business audience that you had in your mind when you were writing this book?
Yeah, I think our audience was our audience was not the Googles, Facebooks, and so on. Mm-hmm. Our audience was the sort of typical CEO of a large service or manufacturing company, sitting there saying, what is this thing, and is it gonna, disrupt us, and what's gonna happen, and where exactly is it gonna impact on our business? Mm-hmm. And so they're asking this question at a time when, what we have are some very good tools, and we also know that for the most part, they kind of have to be developed specifically for your business.
Right.
We haven't yet, although we might see sort of someone selling sort of generic AI platforms, and you can sort of build on that. There's a bit of that going on, but it's not at the same level as, the ability to outsource building a web page or something like that yet.
Sure.
You still kind of need someone who knows your business in order to make good of it. But that was basically the audience. Where do those people start? And our message was, you don't have to panic and rush and start spending millions of dollars on AI and what have you. But there are probably places in your organization you could look to start those pilots, start building up those capabilities. Mm-hmm. At least now. There's another question of what will occur once AI gets better and better and better. There might be bigger changes, but right now it's where can I use this right now? And for us, it is, if it's all about prediction, what you want to be identifying are these situations where you're dealing with a lot of uncertainty. Mm-hmm. And so, a few days ago, I wrote an article, and I'm unfortunately going to forget the name of the company, but it was the typical thing here where a company, I think it was in a grocery business, noticed that 28% of their products had to be thrown out, so there's 28% waste.
Wow.
And so and I don't know if that's typical for things, but one can imagine it is actually. Sure. In fact, I think in most of these food service industries, I think that's a constant thing. Trying to match supply and demand on a basically daily basis is really, really hard. So they realized that, and then they got a data science team, started doing machine learning, became much tighter predictions, and by some order of magnitude, and I can't remember what it is, we're able to significantly slash that wastage.
Wow!
And so that's right.
Yeah,
That's
perfect.
That's the low hanging fruit.
Yep.
That's stuff that's not impossible to do. It probably was partly possible when you had normal statistical rules, but now you can get such a bigger bang for the buck, and people have been collecting the data for long enough, and it can just be thrown into some standard machine learning algorithms that they can get an impact. Now, there's a secondary danger to that, is that, this is the problem with these things. They yield great predictions quickly, but in only the worst possible way.
Okay.
Because you'll run it and you'll say, I want to predict better, and I've got my corpus of data, and I've now reduced the predictive error on it, and so, for the next short while, it does a wonderful job. The problem is that either hidden or because of the data you've collected or something like that, the underlying model that the AI has written of the world to construct these forecasts may itself start to change. There may be other things changing. So, obviously there are things we know, seasonality and other things like that, but there can be changes in the economy and what have you that starts to change that supply and demand, and so the forecasts start to break down. And so the only way around that is to sort of realize it from the start and, effectively, and for want of a better term, push your AI to be more robust.
Yeah.
So in other words, to not take, it's performing really well and as a good sign, but to actually take that as potentially a bad sign.
Interesting.
And you want to sort of knock it about a bit,
Right.
for want of better terms,
Yeah.
to get something more robust.
And it's a kind of a very subtle and insidious form of the overfitting problem, actually.
Well, basically, it is overfitting. That's the problem that arises. I was trying to avoid the technical term, but it's overfitting problem. You can come up, essentially what the AI, if it's super good, it can come up with the theory that explains the past.
Yeah.
And if you apply it to the future, you are going to be wrong.
Yeah.
Because there is no such thing as the theory that explains the past.
Yeah.
And so what you try to do is you try to say to the AI, no, don't do that. And so you throw in some noise and other things, as I said, basically knocking it about to make sure that it doesn't get cocky.
And what's scary about that way that you framed it there is that it actually does work for a bit.
Yeah, no, that's the problem.
Yeah.
It does work for a bit. It
Yeah.
works for a bit. I mean, this happened with Google flu trends. Google was able, out of search results, to predict where the flu was. And it worked wonderfully like the first year, and then it broke apart completely after that, and they had to pretty much abandon.
Why? Do you happen to know?
Well, I think they just overfitted that model.
Okay.
I think, and every year is slightly different, and, why it broke down that quickly, I don't know, but it was not able to. The search terms for, cold medicine and other things were not giving us reliable information, the next year was initially.
Amazing. Maybe you could speak for a minute about how and in what way AI thinks differently from people. It takes in information to kind of have a much narrower view and generates results which are almost, independent of what a person might create.
So,
right?
Well, so I don't know how, people think this way too, but what an AI is doing is still, effectively correlation.
Right.
You can train an AI to predict when the sun is going to come up.
Right.
Now, the way you do that is not by going to Isaac Newton and writing down the laws of gravity and giving yourself all the sizes of all the planetary objects, which is, the traditional way of...
one way of doing it.
One way of coming up with a prediction.
Yeah.
Or Einstein, if you want to get really good. What you do is you sit there gathering data. Suppose you had data of the time of the sunrise and sunsets going all the way back to whenever, and other characteristics, mostly like the temperature, seasons, and other things like that, position on the Earth, what have you. And you could train an AI to predict when the sun is going to rise tomorrow.
Yep.
Or, 3 years' time, or whatever one you want, based on that. But it would be like the statistical association.
Yep.
Now, we know it's going to do a good job at coming up with a statistical association because we already have Newton's theory, so we know there is an answer, right?
Yep.
And so it'll be able to do that.
Yeah.
And so it would come up with that. It might come up with that. I don't know if anyone's tried it. There's some constraints. Newton's theory and the mathematical equations don't have all the sort of linear constraints that sometimes arise in AI models. But let's ignore that for the moment. But that AI, every time the sun comes up, they go, "Well, I'm not surprised. I predicted that."
Yes.
But it's not like they have in their thing, like they knew it was going to occur because they understood
Yep.
that the sun is, the Earth is orbiting the sun and the Earth is turning and all that sort of stuff. So I think that's the difference.
Yeah.
It's like this mere association, and we do things all the time in sort of mere associations and sort of get used to them, probably very implicitly there. But when we're pressed for it, no one says, "Well, that's just how it tended to be." They, come up with it. Why did you, even asking people, and sometimes it's wrong. If you ask people, why do you win or lose at a casino? One way of coming up is, well, I understand the probability of winning here is and this is how many times I won. Or alternatively, they come up with some other explanation regarding luck. But to an AI, this is just, associations. This is my best guess. And that's what happened.
And what struck me about that, and I even wrote it down a second ago to make sure I touched on it, was you're training the AI the same way you're training my kids. Just look at the sun every day, and it comes up now, and I kind of notice the seasons change, and that affects it a little bit. And they could come up by themselves with the Julian calendar, maybe, right? But you're going to wind up messing up leap years and other kind of weird subtleties that you might not pick up.
I mean, certainly years and years ago, that's I guess what was going on.
Yeah.
People sort of came up with a thing, and they could predict that the sun was going to come up once every 24 hours, and might change a little bit over time with the seasons, and they would have seen that association. What the theory of it was behind it wouldn't have been much different. But then, Newton came along and could do a better job. Well, actually, other people did a better job before.
They did.
It did some, you could come up with some models, some causal things. I don't know if that's the way that your kids are learning stuff. I mean, there is a sort of intuitive grasp of physics that seems to come to all living creatures somewhere. And I think we can all pretty much claim most of us do not know those equations.
Yeah.
So,
that's another idea that I read about recently, and I forget the publication that I read it in, but a certain framing of the evolution of intelligence as evolved for physical acts. And so the description that sort of stuck in my head there was the great apes became very intelligent because they were swinging through trees, and the stakes are high when you're swinging through trees, right? Because you could hit stuff, and you got to know where the next branch is, and you got to be able to handle all that. So it evolved a physical quality intelligence.
Right.
And as I kind of reflected on that, I found that really appealing because I think that when I feel like I'm at my most insightful, it's when I'm actually using my intelligence in a physical manner. So I'm actually putting myself in a situation, right? So I don't think to myself, oh, sort of doing the supply and demand graphs. I'm like, so when I talk to this person and tell them this, does my argument feel right? And it's a different way of just kind of writing it down on paper. There's something. I think there's something special about embodiment, about feeling in space and time and putting yourself in a room, even if you're just imagining it, that I think powers up your intelligence.
I mean, certainly there's a thesis about that, and certainly in terms of thinking about how to make robots and other things like that, there's something to the physical embodiment. It's hard to know. I mean,
sure.
I mean, one of the things that has come up in recent years is everybody knew we weren't that much different from all sorts of animals in terms of our genetic material. And, while there were differences in brain size and a bit in brain composition, everybody had a pretty sophisticated brain compared to computers or something like that.
Yep.
But it was a sort of bias for so many years trying to say, what is different about people? Why are we the ones?
Yeah.
And I think the recognition now is we're not the ones.
Yeah.
I mean, we're not the only ones who do things like there are, for instance, crows who have demonstrated the ability to have a theoretical model inside them. What they do is they place inside a test tube a treat sitting in some water, and it's too far for their beak to grab that treat. But what the crows realize is if they drop other little rocks into that, the treat will rise to the top.
Incredible. I didn't
Yes,
know that.
exactly. Or worse still, they've got
buoyancy.
they've got a
They get it.
situation where you can pick up something in the same test tube, and they're given a bendable stick, and the crows fashion it into a hook and then hook it out.
Wow.
Now, that is a pretty amazing set of things.
Yeah.
And I think they're finding that with all manner of
Sure.
animals. And animals really differ in this regard as well, in terms of the ability. So,
Yeah.
crows apparently can do this, other birds can't.
Yep.
Why is that? I don't know.
Yeah.
No one sat there and said, the crow, that's going to be the smart one.
Yeah.
It wasn't
Wasn't well forecast.
Yeah, it wasn't the forecast. But no, they're interesting things. And, and elephants have shown all manner of, ability to remember and know people and stuff like that. So I think that's actually fairly comforting. In some sense. It just shows that there's a lot more, the distance between us and the animals is far closer than we were willing to admit. Mm-hmm. It also shows that, being able to focus your artificial intelligence research on just being able to produce some of the things even animals can do is probably going to be a good place to start in getting you further. So it's really quite interesting.
Yeah, one of the ideas I liked in the book, and this also resonated with me, is you mentioned that humans. This is on the topic of uncertainty. So humans, in humans, a difficult decision is manifest in the amount of time you spend on it. Right. And so you deliberate. You're not sure, and you're thinking about it. And in machines, they don't have the same kind of cost, or they don't experience the same kind of deliberation, I suppose.
Right. Oh, I mean, all machines can take a while to reach an answer.
Yeah.
I think the way we sort of think about it in the book is the problem is the machines can't be told. If you want to automate something, you have to say, if this happens, then you should do that. And you have to specify all of that. You can shortcut that a bit, saying, whatever you do, try and achieve this goal. But either way, someone has to tell the machine the goal.
Yep.
The machine isn't really coming up with the goal. We can have machines sort of adjust something that looks like their reward things, but they've got to have a place to start and things like that. And so that process of thinking about what to do, how to complete those if-then statements, is still something that we as people have to do. Now, it may be that only one person has to do it once, and then it can be coded and spread out. That's a different matter. But, for a lot of decisions that have to do with us personally, it can only be us who do it.
And that the idea, I think that you didn't maybe you can talk about more specifically is the idea of complements. So the humans, because AI becomes becomes cheaper and use it more, actually humans become more valuable, which people might not expect.
Right. I mean, it's the way I like to think of it is without the predictions that AI was giving us, how did we deal with uncertainty? Well, the answer was we tried to insulate ourselves from it. You build a factory floor with very tight environmental conditions and things like that. When you suddenly have better predictions, you are able to adjust your behavior. So rather than having a rule, I'll always take my umbrella, you have a rule, I'll take my umbrella if the forecast says it's likely to rain.
Yeah.
It's just a contingent decision.
Yeah.
You can see why you'd want to do that. And so you can make that trade-off. And when you have predictions coming from AI, you can do that for very, very complicated things and potentially have very, very complicated decisions.
Right.
If I do this, then that, a very complicated thing. However, because you've not made that decision before, chances are you haven't thought about what you would do if you could.
Yeah, interesting.
It's much the same way I like to, when people buy a lottery ticket, why do they buy a lottery ticket? Before you buy a lottery ticket, there's no chance of you winning the lottery. After you buy a lottery ticket, there's also no chance. There is a state of the world in which you are the winner.
Yeah, sure.
And so people said, well, now that I've bought the ticket, I can now think about that state of the world.
Yep.
I can think about that outcome where I win and what I would do with this thing, which is not that much stupid, but, at least it's not possible before you buy the ticket.
Yep.
Of course, you should think about that before you buy the ticket.
You can't win if you don't try.
Yeah. But I think the idea is that, sometimes now that the AI can tell us when this sort of edge event is going to occur, maybe it behooves me to think about what I would do in it. And if I'm not going to think about what I'm going to do in it, then what use is the AI? Because if I'm going to just make the same decisions as I did when I didn't know anything, the AI is of no use to me. It's only useful if it changes what I'm going to do. And if I don't know what to do, it can't do that. And that's the complementarity.
And it makes me think a bit of cognitive bias. So the thought that came to my mind as you were talking there about somebody who, once they buy a lottery ticket, they probably overestimate the probability that they're going to win the lottery now that they have the lottery ticket in their hand.
Yes.
And that's availability bias, well documented. It's in the psychology literature, and Daniel Kahneman won the economics Nobel Prize for it. Now, machines, do they have cognitive biases, or are they just machine cognitive biases that we just think are ridiculous?
Well, I think so. So there's three buckets. One is, if you do it properly, they won't have that sort of cognitive bias.
Right.
So, you could eliminate it. Two is, if you train the machines to make predictions that are the same as what a human would, well, they're going to come up with the same biases that the human.
Right.
So if they're looking at a human, say, do that, well, they're going to do that.
Yeah.
And so they're going to have the same biases. So now, the good news is it might be more transparent, and so you can tell the machine, don't do that. Do everything of the human except for that and see what happens. So there's some hope there, which is not more than we can say for most people. And then there's this third thing, because we know this comes from statistics, biases creep up. Anyway.
Yeah, sure. Yeah.
In fact, the very notion of these predictive algorithms, if anyone's sort of thinking back to their statistics courses, if they ever did it, the goal of it was to come up with an unbiased estimator.
Yep.
Those AI machine learning algorithms don't have that restriction in them.
Yeah.
They're quite happy to come up with biased estimates.
Yeah, as long as it works.
As long as it works. Because there's a difference between, working... biased things can work better than unbiased ones.
Yes.
Unbiased is some sort of, scientific thing that we must not have the truth and blah, blah, blah.
Yeah.
But they don't care about the truth. They care about what works. So, that's the thing motivating it. So it's going to introduce those biases into it. And we know less about what those will look like in particular domains. We may not even be that great at picking them up. So I think, there is this they can do it. But, the law of statistics tells us you got to be careful.
Yeah. Well, I think it's a great bridge into another really important idea in the book, which is that of trade-offs.
Yes.
And so another way of framing that, if I understood it right, is bias is the introduction of bias as a trade-off for accuracy. Right. And so there are lots of trade-offs in AI. Maybe you can talk a bit about some other examples you had in the book of what you must sacrifice in order to gain.
Yeah. So, some of the stuff, and the ones we concentrate on in the book is where you have to, the thing that you're trading off is these, customer experience or something like that.
Okay.
For instance, we know that when you use an app like Waze to, navigate through traffic and things like that. The way that Waze is collecting the data on when there's a traffic problem is by Waze users who are stuck in traffic. Okay, so imagine there's two paths to go. There's using the freeway and using the back streets. The freeway gets clogged, so the app sends people down the back streets that are now better. Now, if it does that to everybody who's using Waze, and that's what they do, they all go on the back streets, how does Waze ever find out that the traffic jam is no longer there? How does it ever find out? Now, one imagines, and I believe this is actually what they do, is they at some point decide, it's likely the traffic jam is gone, let's send some people that way. Okay? Now, that's great for optimizing the system. It's not so great for the sacrificial lamb. That's now stuck in traffic because it turned out that, and that could be really bad. If they're still stuck in traffic, it must be really bad traffic. Now maybe that's part of the deal of using Waze, and you can accept your that sometimes you're going to have this cost. But That's the sort of thing. And anytime we have to put stuff out in the real world, especially if we wanted to learn and update, well, it's not going to be as good initially. So someone's going to be bearing the cost of that. And so, there's this issue of, how well do you train it within your own confines and your own company before you put it out there? We know in the long term, things that are trained out there in the environment they're operating in are going to probably be better. But the short-term cost of that is that they're going to be crappy initially, and
Yes.
that could be, that could be far, far worse. So this is the, just a trade-off that people are going to have to work out, and it sort of depends on the nature of the business.
And I think another way of thinking about it, and maybe let me know what you think of this, is that AI is to some degree an alien intelligence. And so I'm thinking in particular about the chess algorithm, which I forget what it was called. The recent one, the neural networks based one that
I've forgotten.
yeah. Anyway, so you know what I'm talking about,
Yeah,
though, right?
yeah.
And there's kind of a bit of an uproar in the chess community because it was playing very differently than a lot of the other algorithms were, and then a lot of people were, because it learned the game just on its own. And so I'm thinking, and there's an example in my business, in the insurance business, where this can manifest as well, where there's a lot of underwriting of risk is done on an algorithmic basis now.
Yes.
So they'll have a machine which will price the risk, select the risk, and will sell the policies. And what happens though is you wind up with policies or opportunities that fall out of the box. And to a human will look like a very stupid decision by the machine. And so it actually scatters some fruit on the ground that one can pick up if you are willing to just take a very human approach to evaluating the risk, which is distinct, completely separated from the machine look.
Yes.
And it's easy to disparage the machine and say the machines are stupid. Look at all this dumb stuff that they've thrown out.
Right.
But actually, what you're not seeing there is the enormous amount of value the machines are creating. They're doing a lot better, but they're making different kinds of errors than humans would make. And so that's shooting out all this other stuff that humans can then pick up.
Right. And so the answer to the reaction to that, and I think this is going to come up quite a lot, is the reaction that is, stupid machines, we shouldn't rely on them as much.
Right.
Is not the right reaction. The right reaction is, have they discovered something?
Right.
Because, going off the path and other things like that can lead to discoveries. And I think one of the things that we've noticed in some of the sort of more powerful use cases for machine learning is when they go into a new environment, you run these techniques, and then rather than blindly using them, you say, well, why are they suggesting this? And you go back in and and you can play with these models, they're just computers. You can basically do the equivalent of interrogate them, ask them questions, find out what's really driving the result.
Yeah.
And you make a discovery. Oh my goodness, it was this. I didn't think that drove demand at all. I mean, because the theory is there, but it's like implausible to me if I didn't know it. But there it is. Yeah. And so you now say, oh, well, I've now discovered something. So I think actually we're going to, aside from the automation, people coming in and using these tools, and I bet you in insurance in a big way, are just going to discover some other things, discover some, drivers of risk that just weren't transparent before. And obviously once you discover the driver, you can mitigate and insure against that risk. And I think that will be happening. In precisely what avenues and where, hard to say.
Very hard.
But it might be in the sort of like the oldest and stable, driving risk and things like that. It may turn out to be, quite revolutionary.
I'm wondering about what kind of company is good at this. And I want to relate this to a book I read recently called Capitalism Without Capital, which in that book it makes the observation, based on quite a lot of literature that preceded it, that organizations are getting, well, let's call it the intangible capital is becoming a bigger part of organizations. And one of the hypotheses that about what's going on there is that organizations are doing things like building AI. Right. And there's software development that's embedded in the organization, and that's what they're creating, and that's intangible, and that's what's driving the value. There's an observation, of course, that Amazon, these large tech companies, are driven by software at their core, and that's that's what's going on. And that's what an AI-driven organization will look like. Is that the right way of thinking about it? What do you think?
Not really. I mean, I understand those pushes and things like that. My my thought is that I'd be surprised if there's a thing such as an AI-driven organization that basically has automated a whole lot of things.
Yeah.
Or if it is, it just doesn't look that significant. It's gonna be a thing we do, but it's. I think the reason being is that I think when those sort of tasks get automated, it frees up people to do so much more, and there's no way for sure to know this, but just imagine there's always stuff you can do, just in your own jobs. If I didn't have to do this, what would I fill it with? Usually, the answer is rarely nothing. It's rarely nothing. It's just not, priority and other things like that. And I think there's just a lot of more scope for that to do. And so you're going to see AI be used as tools and things like that. I mean, maybe there was some organization, like agriculture that, agriculture became automated, so it became very different. And maybe there are some parts of organizations that will start to look like it's all driven by some, Oracle computer somewhere. But, I just don't see that as widespread. I don't think it's going to fundamentally change the...
So maybe I focus too much on AI in that framing of the problem. So because I'll put the question to you. What is the difference then between these tech startup giants and other large companies or other organizations generally, if that's not that?
Yeah, no. So I think the tech giants had two things going for them. One is they had the capabilities, so we can't discount that. Two is that they were already trying to solve AI-like problems. Google were trying to predict what people would want to click on when they put in a search term. I mean, that's basically their business, or what ad they need to show. So they've got prediction at the heart of their business. They already have the data. Yep. It's like they're the fallow place for this sort of thing. Other businesses, yes, they have prediction, but they don't have the capabilities, data, and everything all set to it. And so it's been spending all their time avoiding predicting. Mm-hmm. And so that's going to be later when those industries unlock and say, okay, I can now do this because I can start to formulate predictions and think differently about the business. And that's a longer process. So it's like, I imagine insurance is always an industry we imagine because it's dealing with uncertainty, risks, so on. It's already becoming a big data industry. It'll be one that will see these tools get deployed fairly quickly. And so I think that's going to happen. But, as you go further and further down, it's going to take a while.
There's an observation about insurance that I've been working in the insurance business a long time now, and it is the case, definitely is the case, that a lot of AI and AI-like tools, or maybe just predictive modeling, let's call it, is making big inroads. But the core of the insurance business is what I like to call a moral economy, which is actually in the face of enormous uncertainty, what humans do is, you're right, they avoid it, but they also make deals with each other and trust each other, right? So creates this network of people and organizations that collaborate, and they more or less say, we don't know what's going to happen here, so let's just sort of agree not to screw each other and have this really long game that we're playing where we're all in this. It's a kind of an insular business in some ways. Right. And there's something deeply human about that. Yes. Right? And there's something that feels to me like very hard, very difficult for computers or machines to replace at all.
Well, it can't replace. I mean, if the industry has already optimally configured itself, the insurance industry can't reduce risk.
Yep.
Whatever risk is out there is out there. It just is. It's all in the business of allocating it.
Yep.
So that some people feel it, so that we reallocate it. Now, if the insurance industry has already worked out how to optimally allocate all the risk that's out there,
nothing more can be done.
There's nothing more to be done.
Yeah, you can make that efficient allocation, but you can make it cheaper, right? So back to the original thesis of the book, right? It's getting cheaper.
You can make cheaper finding what that should be.
Yes. Shorter path, to the answer.
Exactly.
There's one other kind of thought on the insurance business, which is, given back to the complementarity idea of there are complements, and so people who are evaluating each other for trust, they don't trust machines. I think that's what it comes down to.
Yes.
And do you think that's something that can change or will change, or was there always going to be a separation there?
I think, when the machines are reliable, we put an enormous amount of trust in them. Let's think about what we drive around in.
Yeah.
Or what we fly in.
Yeah, that's right.
So what we do ascribe. No, when it works, There's a period at which you're not trusting something, and you can remember when you didn't trust your internet connection or you didn't trust something in some piece of software somewhere.
Yeah.
And then it's fine.
Yeah.
You can start relying on it. And I think the same will be true.
Mm-hmm.
The same will be true.
So running out of time, but maybe we could close on if you have any thoughts about what you think, how you think the industry, or so call it the function of AI, will evolve over the next kind of immediate period of time. How will the cheaper manifest itself? Any forecasts?
No. Well, we try very hard not to make too many forecasts.
I noticed. Too bad.
Well, the problem is that really shortens the lives of these books.
Yes.
I've known from the past that somebody predicting Enron is the future type book doesn't tend to last. I don't have any I don't have any particular insight into like how quickly this is going to roll out and things like that. There's a lot of activity going on. I think. In the next, let's be more interesting. In the next 5 years, there will be a startup somewhere who manages to reformulate what wasn't a prediction problem as a prediction problem, solves it, and it impacts broadly on our lives. The one thing I know about these radical innovations is how they actually ended up manifesting themselves was always different from what people imagined at this stage. And and I think the same is going to be true of AI.
Great. Maybe you can tell the audience where they can get your book, where they can maybe reach out to you on Twitter or any other platform.
So the book is available at all good bookstores, including on audiobook now. You can go to predictionmachines.ai for links to your favorite ones. And I'm also available on Twitter at Josh Gans.
Great. Guest today is Joshua Gans. Thank you very much for being part of the show.
Thank you.